Hello dear friends, welcome to this video. In this video, we'll be seeing this question that if lambda is an eigenvalue of A, then we need to show that the eigenspace of A raised to k corresponding to lambda raised to k contains the eigenspace of A corresponding to A. The first thing we should understand that what has been asked to be shown. There are word used are nothing but the eigenspace. What is the meaning of the word eigenspace of A corresponding to lambda, right? Corresponding to lambda. When I say eigenspace of A corresponding to lambda, I mean collection of all eigenvectors and the zero vector. That means collection of all those x such that my Ax is equal to lambda times x. Correct? This is nothing but my E lambda. I denoted by E lambda. E lambda is nothing but eigenspace of matrix A corresponding to eigenvalue lambda. Now the other thing that they have used is eigenspace of A raised to k corresponding to lambda raised to k. First of all, one thing is clear. If lambda is an eigenvalue of A, then lambda raised to k is an eigenvalue of A raised to k. So definitely lambda raised to k is an eigenvalue of A raised to k, hence it must have some non-zero eigenspace. But when I say eigenspace of A raised to k, that means what? I would be collecting all those vectors I denoted by y such that my A raised to k y is equal to lambda raised to k y. Okay. So these are nothing but two eigenspaces which has been talked in the question. What they are asking that if I denote this by E lambda k, then they are telling me this E lambda raised to k contains my E lambda. Right? So I need to show that my E lambda is contained inside E lambda raised to k. So we just need to show the subset relation, that one is a subset of the other. This is the only thing they are asked. Right? So how you prove one is a subset of other? Take any element in the smaller set that must be inside the bigger set. Correct? So I will start the proof. I'll start the proof like for any capital X inside my E lambda. I need to show that this X must be inside E lambda raised to k. Whenever I say my X is inside this, what do I mean by it? If my X is inside E lambda, that means my Ax must be same as lambda x. I need to prove this. That is what I need to prove. If I say X is an element of E lambda k, that means what? X satisfies this condition. What is that condition? The condition is nothing but A raised to kx is equal to lambda raised to kx. This condition must be satisfied. By using this, I can write, if I consider A square x, this is same as what? A square x is same as A times A into x. Now this Ax is same as what? That is same as lambda times x, and hence this is same as, this lambda is a scalar, I can take it outside. So it is lambda A raised to x. Now again this A raised to x, Ax is what? Ax is nothing but again lambda x. So ultimately what we get? Ultimately we get my A square x is same as lambda square x. And by induction, what we can see that if I consider A raised to kx, I'll get lambda raised to kx. And that implies my x is an element of E lambda k. And hence, what was the claim? Claim is proved. Hence, this part is proved that one is a subset of other. If you see in the question, they have just asked it contains inside that. Nothing else they are asking us. So this is nothing but the required proof. What we have proved? The eigenspace of A raised to k corresponding to lambda raised to k contains the eigenspace of A corresponding to lambda. If you understood the proof, if you have any doubt, please let me know in the comment section. Okay.